Hi, I am Dr. J. Suresh Goud, Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, we are going to discuss problems on sampling distribution. As we have discussed in the previous session, the same topic, problems on sampling distribution, this is the extension of the problems on sampling distribution. In the previous session, we have discussed the population with the sample size 2 and with replacement and without replacement we have completed. Now we are going to discuss the problems on sampling distribution with the population size different and sample size also different. That is the main difference between the previous session and this session. See, consider the problem. A population consists of 5 numbers, 4, 8, 12, 16, 20, 24. So 6 numbers. Consider all possible samples of size 2. Consider all possible samples of size 2. Sample size is 2 and population size is 6. So capital N equal to 6 and small n equal to 2. Which can be drawn without replacement. Which can be drawn without replacement from the population. We are going to find out the mean of the population, standard deviation of the population, mean of the population we should find, and variance also we should find. Then only we are going to get standard deviation. And mean of the sampling distribution, similarly the standard deviation of the sampling distribution. These two problems are related to population and these two problems are related to sampling distribution. According to the problem, capital N, population size given 6 and sample size we have to choose 2. Capital N equal to 6 and each population, first population is given 4 and second population x2 8 and third population x3 12 and fourth population x4 16, fifth population 20 and sixth population 24 with size 6 and sample size 2 is given, small n equal to 2. Now first we need to find out the mean of the population. The mean symbol mu, which is nothing but sigma xi by capital N, the average of all the populations. Means add all these terms, 4 plus 8 plus 12 plus 16 plus 20 plus 24 by population size is 6 because capital N equal to 6. So 84 by 6, 14. So mean mu equal to 14. That means the mean of the population we completed, which is 14. Now, the standard deviation of the population. To get this value, the standard deviation of the population, first we need to find out the variance of the population. If you get the variance of the population, we can find out standard deviation by taking the under root of variance of the population. So, the variance of the population, formula sigma square, sigma capital Xi minus mu whole square by n. And this n we know that which is 6. We have written 6. And xi values x1, x2, x3, 4, 8, 12, 16, 20, 24. And mean we got it which is 14. So xi minus mu whole square means 4 minus 14 whole square. 4 minus 14 whole square plus sigma is there. That's why x2 minus mu whole square, 8 minus 14 whole square plus x3, where x3 is 12. 12 minus 14 whole square sigma. That's why plus x4. x4 is 16. 16 minus 14 whole square plus 20 minus 14 whole square plus last one x6, 24 minus 14 whole square by 6. So 4 minus 14, which is 10 square, minus 10 square 100, plus 8 minus 14, minus 6 whole square 36, 12 minus 14 whole square 4, plus 16 minus 14 whole square, which is 2 square 4, and 20 minus 14 whole square 6 square 36, 24 minus 14 whole square 10 square 100 by 6. So variance sigma square equal to 46.67. Therefore, the standard deviation sigma equal to under root of 46.67. This is the standard deviation of the population. Now, so the problem consists of 4 sub questions. First 2 questions are completed, mean and standard deviation. Now we are going to discuss mean of the sampling distribution and variance of the sampling distribution, or SD of the sampling distribution. To find these values, first we have to choose how many samples we can draw without replacement case. That is sampling without replacement. Sampling without replacement. What is the formula without replacement? NCN, where capital N equal to 6, C sample size small n equal to 2. 6C2 equal to 15, because NCR formula we are going to use n factorial by n minus r factorial into r factorial. According to that, 6C2, where capital small n equal to 6, small r equal to 2. 6 factorial by 4 factorial into 2 factorial, which is 15. That means we can draw 15 samples. We can draw 15 samples without replacement case. Actually, the populations are 4, 8, 12, 16, 20, 24. With the sample size 2, we have to choose the samples. First one, 4, 8. Not replacing 4, 4, we are not going to consider because it is without replacement case. Next, 4, 12, 4, 16. Next, 4, 20. Next, 4, 24. So 4 concept completed. Now starts with 8. We are not going back to 8, 4 because already 4, 8 we have taken. Because it is without replacement case, we are not going to replace again either 4, 8. We have taken 4, 8. No need to take 8, 4 because both are duplicates. Now starts with 8, 8, 12. Next, 8, 16. Next, 8, 20. Next, 8, 24. So 8 concept also over. Next, 12. 12, 16. 12, 20, 12, 24. 12, 16. 12, 20. 12, 24. Size 2. Only 2 elements. 12 also completed. Next, 16. 16, 20, 16, 24. 16 also completed. Next, last 20, 24. So these are the samples with size 2 without replacement case. Without replacement case. Totally how many samples? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Totally 15 samples we have drawn from the population size 6 with the sample size 2 in without replacement case. In case the problem consists of with replacement, it will be changed. The number of samples will be changed. But in the problem consists of without replacement, we are going to choose only NCN samples. After getting the samples, this is the first sample 4, 8. We can denote it with X1. Next, second sample, we can denote it with X2. Third sample, X3. Fourth sample, fifth sample. Lastly, X15. 15 samples are there. Now, we are going to find out all these 15 samples means. That is, mean of all the samples are. Mean of all the samples are. Suppose If you go to the first sample 4, 8, its mean is, the first sample mean is 4 plus 8 by 2 average 6. So this is the first sample mean, that's why bar, x1 bar. Coming to second one, 4, 12, x2. This is a sample. Its mean 8 because 4 plus 12, 16 by 2, average 2. This is x2 bar. 4, 16 mean 10 because 20 by 2. 4, 20, 24 by 2, 12. 4, 24, 28 by 2, 14. Similarly, 8, 12, 20 by 2, 10. 8, 16, 24 by 2, 12. 8, 20, 28 by 2, 14. 8, 24, 32 by 2, 16. 12, 16, 28 by 2, 14. 12, 20, 32 by 2, 16. 12, 24, 36 by 2, 18. 16, 20, 36 by 2, 18. 16, 24, 40 by 2, 20. Finally, 20, 24, 44 by 2, 22. All samples means we got it. This is the first sample mean x1 bar, second sample mean x2 bar, third sample mean x3 bar, and so on. Last sample x15, its mean is x15 bar. Now we know the values of x1 bar, x2 bar, and so on x15 bar. All 15 samples means we got it. Now based on these means of the sample, we are going to calculate the mean of the sampling distribution and variance of the sampling distribution. The mean of the sampling distribution formula, the symbol is mu x bar, 1 by NCN into sigma xi bar. In the previous slide, we got it x1 bar, x2 bar, x1. Its average of all the means, we are going to get 6, 8, 10 and so on, 22 by total number of samples are 15. NCN is 15 now. So mu x bar equal to 14. And if you observe that in the same problem, mean of the population also we got it 14, and this is mean of the sampling distribution also 14. So remember this point, mu is always equal to mu x bar. That means mean of the population, similarly mean of the sampling distribution are always equal. Next, coming to variance of the sampling distribution, the symbol is sigma square x bar. 1 by NCN sigma xi bar minus mu x bar, where mu x bar equal to 14. 1 by NCN 15, xi bar, the first value 6 minus 14 whole square, where 14 is mu x bar, plus 8 minus 14 whole square. This 6, 8, 10 and so on are the mean of all the samples. 6 minus 14 whole square, 8 minus 14 whole square, 10 minus 14 whole square, like that. So if we simplify, variance of the sampling distribution 18.67. So after getting variance of the sampling distribution, we can find out standard deviation of the sampling distribution sigma x bar, which is under root of sigma square x bar under root of 18.67. This is standard deviation of the sampling distribution. So in this problem, we calculated mu and sigma, standard deviation of the populations. Similarly, mu x bar and sigma x bar. But remember that these two are equal always. Now, coming to the next problem, this is in another perspective. A population consists of 3, 6, 9, 15, 27. With size, population size 1, 2, 3, 4, 5. Capital N equal to 5. And first population is 3, second population is 6, third population is 9, and fourth one is 15, and fifth one is 27. Here, consider all possible samples of size 3, not size 2. In the first 3 problems, we discussed all the problems with sample size 2 only. But here, we are going to discuss the sample size 3 that can be drawn without replacement. Without replacement means how many samples? NCN samples from its particular population. Find again mean of the population, mean, standard deviation of the population, mean of the sampling distribution, and standard deviation of the sampling distribution. These two are related to population and these two are related to the sampling distribution. Now, in the solution, given that capital N equal to 5, small n equal to 3, the first two we can find out very easily by using the formula mu sigma xi by n, where xi, x1 plus x2 plus x3 plus x4 plus x5. That means 3 plus 6 plus 9 plus 15 plus 27 by 5. So, mu equal to 12. So, this problem we got it. And to get the standard deviation, we need to find out variance, obviously. The variance of the population, formula sigma square equal to sigma xi minus mu whole square by n, where capital N equal to 5, mu also we got it 12 in the previous slide, and x1 3 minus 12 whole square, plus where x2 is 6 minus 12 whole square, x3 is 9 minus 12 whole square, x3 minus mu whole square, plus x4, where x4 is 15 minus 12 whole square, x5 27 minus 12 whole square. Sigma square is 72. Then standard deviation is equal to sigma under root of 72. Now, before going to discuss subproblem 3 and 4, mean of the sampling distribution mu x bar and variance x bar, we need to find out how many samples we can draw according to the problem. In without replacement, we know that NCN samples, capital N is 5, small n is 3, because sample size is 3. 5C3 means 10 samples we can choose. Actually, populations are 3, 6, 9, 15, 27. This is the population size. I need to choose 3 samples, not 2 samples. In the problem consists of 3 samples from this population. How we choose? How we choose these 10 samples? First, you fix 3 samples. 1, 2, 3. First, you fix 3. This is I fixed. Remaining 2, maybe 6, 9. 6 also you fix in the second position. This will be changed, third position, either 9 or 15 or 27. That means 3, 6, 9, 3, 6, 15, 3, 6, 27. So that 3 I written, 3, 6, 9, 3, 6, 15, 3, 6, 27. First one fixed, second position also fixed. Now I am going to change second position to 9. First one fixed, second one also 9 fixed. Third one 15. This 15 may change 27. 3, 9, 15, 3, 9, 27. Like that. 3, 9, 15, 3, 9, 27. The same 3 fixed, but second position, first case 6 completed, second case 9 completed. Third case 15 fixed. 15. The last term is 27. 3, 15, 7, 27. With the starting number 3, the second position I changed once 6, once 9, once 15. With the starting number 3. Now, I am going to change the starting number with 6. 6. And remaining 2 positions. 9 also fixed. Third position fixed. 15. And third position we can change 27. 6, 9, 15, 6, 9, 27. 6, 9, 15, 6, 9, 27. If I change the second position as a 15, 6, 15, 27 also we are going to get. So 6 also completed. Now the last 9, 9, 15, 27. Like this, we have to choose samples with the size 3. Samples with the size 3 in without replacement case. In without replacement case. So this is the first sample, which is denoted by x1, and the second sample x2, third sample x3, and so on, 10th sample x10. But to find mean and variance of the sampling distribution, the samples are not enough. The mean of the samples are required. That's why we have 10 samples. For this 10 samples, we are going to find out mean of each sample. Suppose if I take the first sample 3, 6, 9, its mean. That means average of these 3 plus 6 plus 9 by 3, 6. So this is mean of the first sample, which is denoted by x1 bar. Now coming to the second sample 3, 6, 15, its mean. The second sample mean, which is 8, x2 bar. Now third sample 3, 6, 27, 36 by 3, 12. Third sample mean. This is fourth sample mean. Like that, fifth, sixth, seventh, eighth, 10th sample. 9 plus 15, 24 plus 27 by 3, which is 17, x10 bar. So we got it x1 bar, x2 bar, x3 bar, and so on, x10 bar. So we got all the means of samples, 10 sample means. By using this data, we can find out mean and variance of the sampling distribution. The mean of the sampling distribution, which is denoted by mu x bar, formula 1 by NCN sigma xi bar. Here, why we have taken NCN? Because it is without replacement case. In case if it is with replacement case, we can replace with n power n. But in the problem consists of without replacement, we can use 1 by NCN sigma xi bar, where NCN is 10. And xi bars, we got it the mean of all the samples 6, 8, 12, 10, and so on 17. So we got it 12. Mu x bar equal to 12. And in this problem, first sub question is mu, which is also 12. Mean of the population, mean of the sampling distribution. Always both are equal. After getting this mu x bar equal to 12, we can find out variance of the sampling distribution, which is sigma square x bar, formula 1 by NCN sigma xi bar minus mu x bar, where mu x bar equal to 12, where xi bar is 6, 8, 12, and so on 17. That means 6 minus 12 whole square plus 8 minus 12 whole square, and so on. Last xi bar is 17 minus 12 whole square by NCN. So sigma square x bar equal to 12. Therefore, the standard deviation of sampling distribution, which is sigma x bar under root of sigma square x bar root 12, which is 3.4, and so on. So like this, we have to solve the problems on sampling distribution. The main focus here only on mean variance standard deviation of population, similarly mean variance standard deviation of the sampling distribution. When we are finding mean variance and sampling distribution of the sampling distribution, we require how many samples we are going to choose, how we are going to choose, that is with replacement or without replacement. Accordingly, we have to write all the samples, then you find out mean of all the samples. After that, we can find out mean, variance, and standard deviation of the sampling distribution. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.